All right, so this is the video for the 8H handout. I'll make sure. Okay. Yeah, okay. So this deals with what's called right triangle trigonometry. And there are these three things here that are called the trigonometric ratios, the most common ones. They're called sine, cosine, and tangent. And the way that they work is you pick an angle, like in this case it's angle A over here, and you call it your reference angle. And then based on the reference angle, you've got three types of sides. You got an opposite side, which is pretty easy. You've got an adjacent side and a hypotenuse. So it's got to be a right triangle. So the hypotenuse is easy. Adjacent means next to, and really, when you pick an angle, you've got two sides that are adjacent to it. You've got, like if this is my reference angle, I've got this side is adjacent and this side's adjacent. But since this one's already called the hypotenuse, we just call the non-hypotenuse side that's connected to the angle the adjacent one. Okay? And then there's these, the rules for these three trig functions is that sine of your angle is always the opposite side of the hypotenuse. Cosine of the angle is always the adjacent side of the hypotenuse. Tangent of the angle is always the opposite side over the adjacent side. So this won't make a ton of sense until we actually start doing some problems with them. So let's just jump in and see what happens. So in number one, it says use R as your reference angle. So there's R. There's my reference angle right here. Okay. So what we can do then is label our sides based on that angle. So the opposite side is always the one furthest away. And then there are two adjacent sides. There's this one and this one. But the one opposite the right angle we're going to call the hypotenuse instead. And then this side, the other side connected to the angle, is called the adjacent side. And then it says give the sine, cosine, and tangent ratios for R. By the way, this symbol here, theta, that's a Greek letter that gets used often when you need an angle. It's used just like when you don't know a side, you often call it X, Y, Z, A, B, C, something like that. A lot of times Greek letters are used for angles, although not always. Sometimes you still use regular letters too. So we're going to want sine of R. By the way, sin, cos, tan, those are abbreviations for sine, cosine, tangent. So sine of my angle, now we could call it theta. We could put it like a little theta there and call it theta. But since R is already the angle, we can just use capital R here. So sine of R equals the opposite side, which is TS, over the adjacent, the hypotenuse, which is RS. And then cosine of R is going to be the adjacent side over the hypotenuse. So that's going to be RT over RS. And then tangent of R, tan of R is going to be the opposite side over the adjacent side. So TS over RT. Okay, so there's number one. So if we choose a different angle as our reference angle, right here, angle S, then some of these switch up. So angle S, the opposite side is going to be RT. The hypotenuse stays the same because it's opposite the right angle. And now TS becomes the adjacent side. So if I set up sine of R, or sorry, not R, S, sine of angle S, cosine of angle S, and tangent of angle S. Well, let's see if I can fit this all on one screen. There we go. So here's the key right up here. So sine is opposite over hypotenuse. So that's going to be RT over RS. Cosine is going to be adjacent over hypotenuse, so TS over RS. And tangent is going to be opposite over adjacent, so RT over TS. By the way, there's a word that gets used in pretty much every American class that teaches trig, these three trig things. It's this word right here, Sohcahtoa. And the reason that word comes in handy, it's an acronym. If you look at it, they all have the same form. Something of the angle equals some side over some side. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. tangent equals opposite over adjacent. So if you remember that pattern of something of the angle equals side over side, this tells you what goes with what. SOH, CAH, TOA are these guys right here. Right. Okay. Let's look at 3. And I'll just write the word here again. Sohcahtoa. Okay. So why can't we do number 1 again, but instead use angle T as our reference angle? So if we tried to label our sides, well, this side's the opposite side. This side is also the hypotenuse, which is fine. It can be both. The problem is I don't know which side to pick for the adjacent side. There are 2 different adjacent sides. So the issue here is the adjacent side, or if we choose the right angle, if we use the right angle as our reference angle, then we can't, then let's say we get 2 different adjacent sides. Which is a problem because if you're trying to solve some problem that says, cosine equals adjacent over hypotenuse, you have no way of choosing an adjacent side. You can't just decide which one will be adjacent and which one won't. Okay, so let's try some problems. So we'll do 4 and 5. We'll probably skip 6 because it's just a repeat of the same ideas. So in the problem, we got 48 degrees here. That's going to be our reference angle. So if I label the sides, here's my opposite side, here's my hypotenuse. So then the 10 has to be the adjacent side. So if I wanted to solve for x, I know that I'm going to involve the side that's labeled x, the opposite side. And then I'm not also going to involve the y, because there's no way to solve for x and y at the same exact time. But I could involve the 10, because that's a nice number. So if you think about those 3 trig ratios, sine, cosine, and tangent, the one that uses the opposite and adjacent sides are the tangent, TOA. Right? So, and I'll rewrite, this is sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, tan of theta equals opposite over adjacent. Okay, so the one that uses opposite and adjacent is tangent. So let's set up our problem here. Tan of 48 is going to be the opposite side over the adjacent side. So to get x by itself, I could just multiply both sides by 10, and we get this. 10 tan 48 equals x. So let me open up this calculator here. Now the calculator, you're going to need to get in the habit of checking the mode. So just like there's 2 ways to measure lengths, like meters versus feet, if you're working in the wrong units, you end up with the wrong answers. So there are 2 ways to measure angles. One is radians, one's degrees, and the default on our calculators is radian. So you're going to have to come down here, switch it to degree, and hit enter on it so that it selects it. And then I'm going to hit second quit. You can also hit clear in this case to get out of that menu. So now I'm in degree menu. And then all I have to do is type in 10 tangent of 48, 10 tan 48, and hit enter. And there's my answer for x. X is about 11.106. Right? You can kind of see 10 is here. This looks almost like it's roughly around 10. So 11 is pretty close. Okay, to get y, we could do a couple of things. At this point, we know what x is, so you could use Pythag, but that would require us to use this kind of rounded, ugly number. So instead, let's try another trig one. So if I want to solve for y, I can use the hypotenuse. Well, I have to, because that's what y is. And then you could use the rounded number for x, but it's probably easier to use the 10, because that's a nice clean number. So that's the adjacent side and the hypotenuse. And that one is covered by cosine. So if I do cos of 48, that'll be the adjacent side 10 over the hypotenuse y. Now, I want to get y by itself, but it's stuck in the denominator here. When it's a nice number in the denominator, you can just multiply it over and you're done. This one, if I multiply it over, I'm going to get y times cos 48 equals 10, which is a little bit nicer because now y is not stuck in the bottom. And then to get the y by itself, I'm actually going to divide both sides by cos 48. So these guys cancel, and I'm left with y equals 10 over cos 48. And that will end up being 10 divided by cos 48 equals 14.945-ish. So I'll do approximately equals to. So there's y, and here's x. Okay. Let's take a look at the next one. So in the next one, we're also solving for x and y. Here's my reference angle. You could solve for the 40 that's missing in this problem and use that as your reference angle, but that's just extra work. So if 50 is the reference angle, 15 is the opposite side. Y is not the hypotenuse, so it's got to be the adjacent side. And x is opposite the right angle, so it's the hypotenuse. So let's solve for x first. So you know you got to use the hypotenuse. And then you can't use two unknowns at the same time, so we're going to use the 15. So I'll move these down. So the one that uses opposite and hypotenuse together is sine, right? So if I set up my trig ID here, trig formula, I've got sine of the angle, which is 50, equals the opposite side divided by the hypotenuse. So you can multiply the x over. If you prefer, some students like to think of this as over 1 and then they cross multiply. So it's 1 times 15 equals x times sine 50. And then to get the x by itself, we're going to divide both sides by sine 50. So then x is going to be 15 over sine of 50. And then I'll plug that into the calculator. 15 divided by sine 50. And we get 19.581. Okay. So then let's solve for y. When I solve for y, you know you're going to have to involve the adjacent side. And I don't want to deal with using the hypotenuse because that's some kind of ugly number here. You could use it if you wanted to, but I'd prefer to use 15 because that's a nicer number. So opposite and adjacent is involving tangent here. Whoop. So if I set up my trig function, I got trig ratio, tan of my angle, which is 50, equals the opposite side over the adjacent side, y. So again, the letters in the bottom, if I put tan over 1, then I've got 15 times 1 equals y times tan 50. And then if I divide both sides by tan 50, those go away, and I get y equals 15 over tan 50. 15 divided by tan 50 equals 12.586 about. So there we go. Okay, I'm going to skip 6 because 6 is really just a repeat of 4 and 5, just with different numbers. So let's take a look at 7. By the way, trig is going to be the most applicable thing you learn in geometry, in my estimation. If you go into any type of engineering or a lot of sciences, they use trig all the time. So, so we'll do a couple basic word type problems that show you how it can come in handy. So one of the things, cloud sealing is when it's overcast and you look up at the sky and you can kind of see that the clouds look pretty flat overall. So they're all roughly at the same height. And so one of the ways that you can detect how high up the clouds are is you shine a little spotlight straight up onto the clouds. And then not right underneath the spotlight, you actually have a little weather station. And from the weather station, you can measure this angle. And in this problem, the angle of elevation here is 35 degrees from the ground up to where you're measuring from, up to the line of sight. Well, the spotlight's shining straight up, so that's a right angle. And then the other thing that's easy to measure is how far the weather station is from the spotlight. Right, this is where the spotlight's shining up. Whoop. Right here. So this is 200 meters. So if you look at this, we really just have a problem that looks like this. This is 200, this is 35. And we care about how high up the clouds are, so this thing right here I'm going to call x. Well, I don't care about the hypotenuse, so I don't need that. Here's my angle. This side is opposite, this side is adjacent. So the trig ratio that uses that, I'll scroll this down again. The trig ratio that uses that one is tangent. So I'm going to write over here, tan of my angle equals the opposite side over the adjacent side. If you wanted to think of this as cross multiplying, well then I'm just going to have 200 times tan 35 equals x times 1, which is just x. And so then I can just type in 200 tan 35. 200 times tangent of 35 degrees equals 140.042. And in this, these are going to be in meters. So that's how high up the clouds are. Okay, let's look at 8. So 8 is talking about something called a clinometer. And clin is related to incline. An incline is related to how steep something is. It's if you change the angle of inclination, you change how steep it is. And meter is measuring. So this is about measuring angles. And what they've got is some surveyor is measuring the height of some skyscraper here. So there's my skyscraper. Here's the surveyor. I don't know why I care about the hair. So there's the surveyor. And so she's measuring from her eye, she measures up to the top of the building that there's an angle of inclination or an angle of elevation from her eye to the top of the building is 82 degrees. And she's standing 150 feet from the base of the building. Now, we're going to assume that the building is right angled here, that it's perpendicular to the ground, not slanted. Well, I can't put the 82 anywhere yet because I haven't actually drawn an angle from her eye. I've just drawn a line floating around from her eye. So really the angle of inclination or elevation goes from her eye forward directly across to the building and then up to where she's looking. So this is 82 degrees. And then this blue line that's the bottom of the triangle, that's also 150 because it's just straight across. So I'm going to call this part x right here. Now it also mentions that her eye is 4.5 feet off the ground. So let's deal with the blue triangle up here first. X is the opposite side. 150 is the adjacent side compared to the 82. So the one that uses opposite and adjacent is tangent. So I'm going to set up tangent of my angle equals the opposite side over the adjacent side. And then if I put that over 1 and cross multiply, I get 150 times tan 82 equals x. And then if I work that out, I'll get x is about 1,067.305 feet. Well, that's not actually the height of the building. That's just this part. I still have to add in the extra 4.5 feet down below, which is this part right here, because that's how tall her eye is. So the height of the building is going to be 1,067.305 plus the 4.5 extra feet. So that's going to end up being 1,071.805 feet. Okay. Before we do 9, I'm just going to mention something. So like if I said, pick a number on the number line. So you pick some number right here. And then I say, like, let's say we pick 7. And then I say, I want you to do something specific to the number, like triple it. So you triple it, and you end up at 21. And then I say, do the opposite of that to your new number. So if I said triple it, then the opposite of that is divide by 3. If you divide by 3, you end up back in the same place. Okay, so you get back to your original number. If I said, instead of triple it, I said add 10, then you end up at 17. If I said now do the opposite of what you just did, you'd subtract 10 and you'd end up back at 7. So that going backwards idea is, so going forwards is just doing something to it. Going backwards is performing the inverse of what you just did. That's the math way of thinking of it. Okay, so that's going to come in handy in our next problem. So in this one, notice we're missing the angle, but it says just set up a normal trig ratio first. So in this one, let's see, we've got the opposite side, we've got the adjacent 9, and we've got the hypotenuse 15. So if I were to set up, let's say, sine of my angle, in this case the angle I don't know, well, sine of an angle is opposite over hypotenuse. So the opposite side is 12, the hypotenuse is 15. What I want to do is I want to get rid of the sign that's in front there, but I'm not allowed to divide by just sine with nothing next to it. It's not a thing. Like, you can even try it if you wanted. 12 divided by 15 is 0.8. And if I said divide that by sine, notice it opens the parentheses. It needs something there. If you just try to hit enter, it gives you a syntax error because that doesn't actually make any sense. So what we need to do, so what we've done is we've taken the angle and we've done sine to it. So now we have to do the opposite of sine to what we got. And there's a reverse sine button on your calculator. It's called inverse sine. So what we want to do, we'll use inverse sine on both sides. So the inverse sine isn't actually written as inverse sine. It's written like this: sine inverse, sine to the -1. So what I'm going to do is I'm going to rewrite the formula that I just had, but in front of each side, I'm going to say, let's do the opposite of sine, sine inverse. So if I take theta, I do something to it, and then I do something to it like sine, and then I do the opposite of it, sine inverse. I just get theta back. So then this thing, I can type into a calculator. Sine inverse of 12 over 15. The sine inverse button is the same as the sine button, but it's in blue here. So I have to hit the blue button, then sine, and I get sine inverse. Whoops. Then I'm going to plug in 12 over 15 and hit enter. And we get 53.130 degrees. You can kind of think of it like the sine and sine inverse cancel each other out, and you're left with just theta. Now, I'll warn you, what I'm writing here will work for every problem we do in our class, but it's actually not correct to write it like that. You should never actually go from sine theta equals 12 over 15 and then write sine inverse in front of this side. Typically, what you're going to want to do is just go to theta equals sine inverse of 12 over 15. Now, I'm not going to take off if you do this, because I think this idea gets at what you want to understand. But eventually I'll ask you guys to stop writing it quite like the way where we put the sine inverse in front of the left side. Okay, let's do this one other way. Let's say instead of sine, I want to use adjacent and opposite. So the one that uses the adjacent and the opposite is tan. So tan theta is opposite over adjacent. So if I write this out, tan theta equals the opposite side over the adjacent side, then what I want to do to get rid of the tan is do tan inverse. So I'm going to do tan inverse of tan of theta equals tan inverse of 12 over 9. So then these guys go away, and I'm left with theta here equals tan inverse of 12 over 9. Well, here's tan inverse, second tan, 12 over 9, and you get the same answer, 53.130 degrees. Okay? And again, what I want you guys to eventually start doing is write out this first step, and then the second step, instead of writing tan inverse in front of both sides, you would just go straight to theta equals tan inverse of 12 over 9, and then get that. So the key here is when you're solving for a missing angle, you're going to use inverse trig. When you're solving for a missing side, you use regular trig. Okay, we'll do 10, and then I'll probably stop there for now. So 10, we've got ABC is isosceles. AB and AC are both 8. BC is 6. And we have to find the measurement of angle B and the length of its altitudes. So measurement of angle B, you can't use trig on this triangle because it's not a right triangle. But since it's isosceles, if I chop it right down the middle, or if I draw on that altitude, it happens to hit the midpoint on the bottom here. So this is 3 and 3. So now what I've got is I've got a right triangle to work with where I know this is 3, this is 8, and this is angle B. So if I figure out what, let's see, this side is adjacent, and this side is hypotenuse. So the one of the 3 trig functions, sine, cosine, tangent, the one that uses adjacent and hypotenuse is cosine. So cosine of my angle equals the adjacent side over the hypotenuse. And then if I do cos inverse, of both sides, then I just get B over here. Now again, you're really going to skip this step eventually and just go straight to this step, because even though this works for our class, it doesn't work when you get into more advanced trig. So this we can type into the calculator. Cos inverse, so second cos of 3 divided by 8 equals 67.976 degrees roughly. By the way, since the big triangle is isosceles, angle C is also 67.976 degrees. Okay, we need to find the altitudes also. Well, this altitude is just this line right here. We can solve for that using Pythag. So 3 squared plus x squared equals 8 squared. So that's going to be 9 plus x squared equals 64. So x squared will be 55. So that means x is root 55. That's the altitude from angle A. If I wanted to draw the altitude from B, that's like treating this as the ground, and this is the top of the mountain, and you need a right angle there. So this is the altitude from B, and this is the altitude from C. And if you look at it, since it's isosceles, these two altitudes are going to be the same. All right, sorry, I had to pause for a second. But so we're looking for these altitudes that come from B and from C. So let me redraw the triangle so that, let's say, C is at the top. So AB is at the bottom, and let's say this is AB. And then C would be about here instead. So there's C. So this is 8, this is 8, this is 6. Oh, no, wait, did I mess this up? Yeah, I messed this up, sorry. Here's C. This is 6, this is 8. And if we find the altitude right here, that's the same. That's the altitude from C. That's the same as the altitude from B, based on this original picture over here. Well, we know angle B is 67 degrees right here, 67.976 degrees. And I'm looking for this side, which I'll call Y. So you can actually use trig on this little right triangle right here, which I'll draw by itself down here. 6y, angle B is 67.976 degrees. So y is the opposite side, 6 is the hypotenuse. So the one that uses opposite and hypotenuse is sine. So sine of my angle equals the opposite over the hypotenuse. And in this case, I'm solving for that number on top. I can just multiply the 6 over. 6 sine 67.976 equals y. And if you plug that into your calculator, so it's 6 times sine of, now the answer is already here with all the decimals, so instead of rounding it, I'm just going to come up here and hit enter on that, and it cuts and pastes it, and there's my answer. Y is 5.562. So this is the altitude from C and the altitude from A. Oh, sorry, B. There we go. Okay, hope that helps some. I'll post another video soon that has the other problems on it. All right.